Hello friends, in today's class we are going to see the working of piezoelectric transducer. First let us see the principle of piezoelectric transducer. So piezoelectric transducer works on the principle of piezoelectric effect. So let us see what is piezoelectric effect. So the phenomenon of generating an electrical charge in a material when subjected to mechanical stress is called piezoelectric effect. The phenomenon of generating electrical charge in a material when subjected to mechanical stress is called as piezoelectric effect. Now let us see what is piezoelectric effect. Now let us consider a non-conducting sample, that is I am taking a quartz crystal. So when a pressure is applied to both the ends of this quartz crystal, what happens? The crystal will expand along this y-axis and it is compressed along this x-axis. So when a pressure is applied to both the faces of the crystal, it expands along y-axis and it compresses along x-axis. So when this happens, charges will develop on the opposite sides of the crystal, that is one side of the crystal gets positively charged and next is other side of the crystal gets negatively charged. So charge developed on the crystal. Due to the application of pressure on both the sides of the crystal, this charge inside the crystal varies and the variation in the charge can be measured as an electrical voltage. In this reverse case, when a crystal is subjected to tension, that is when the crystal is stretched. When it is stretched on both the ends, the crystal will expand along the x-axis and compress along the y-axis. So the charges will develop on both the sides of the crystal. In this case, it is reversed to the first case. When the tension is applied, the lower plate acquires positive charge and the upper plate acquires negative charge. So and the charge in the crystal varies depending on the tension applied on this crystal. So the variation in the charge can be converted into an electrical voltage. So the phenomenon of generating electrical charge in a material when subjected to mechanical stress, that either it is a pressure or tension, is called as piezoelectric effect. Now let us see what are all the materials exhibiting piezoelectric effect. So first one is quartz. So it is a widely used material used for piezoelectric effect and it has good piezoelectric activity and the cost is also low, so it is inexpensive. The second one is Rochelle salt. So it has greatest piezoelectric activity but it is mechanically weak, so it breaks easily, so it is not widely used. And the third one is tourmaline, which is strongest among the other two material, but it has least piezoelectric effect, so it is not widely used and also it is expensive. Now let us see the basic piezoelectric pressure transducer. Generally we know what is a transducer. So here the piezoelectric pressure transducer converts the mechanical force which is applied, that is pressure, into an electrical voltage. Here the force or pressure which is applied is converted into an electrical voltage. Now let us see the diagram for piezoelectric transducer. So piezoelectric transducer which is used to convert mechanical force into electrical voltage is a active transducer. We know that active transducer is nothing but it does not require any power for its operation, and the components in this piezoelectric transducer is, first one is the pressure point where the pressure is applied, that is external mechanical force is applied in the pressure point. The second one is the force summing member. So force summing member will collect all the forces applied at this pressure point and it concentrates all the force onto this crystal. The third one is the quartz crystal, which is placed in between the force summing member and the base. This quartz crystal is used to produce the charge required, that is it converts the pressure into charge, and this charge can be measured with the help of this metal electrode which is placed on the outside of this crystal. So this metal electrode is used to measure the output voltage or the charge which is developed due to the application of pressure on this crystal, and the base which is below the crystal supports the crystal at one end. These are all the various components in this piezoelectric transducer: pressure point, force summing member, quartz crystal, metal electrodes, the metal electrodes which is used to measure the output voltage and the base. These are all the various components in a piezoelectric transducer. Now let us see the working of piezoelectric transducer. So when the mechanical force or the mechanical stress or the pressure is applied at the pressure point, what happens is the force summing member concentrate all the force applied at this pressure point into the crystal. So this makes the crystal, when the force is applied on the crystal, this makes the crystal to compress along y-axis and expand along x-axis. So the crystal is deformed. So this deformation of the crystal, that is the compression and the expansion of the crystal, this deformation changes or develops charge on the opposite sides of the crystal, and the charge changes based on the force applied, and this charges is measured with the help of this metal electrodes. So these electrodes become the plates of a parallel plate capacitor. It acts as a charge generator. So it measures the charge generated on this quartz, and the magnitude of the potential between these two phases is proportional to the deformation which is produced on this crystal. So the output voltage which is measured can be given by charge by capacitance. So the output voltage V0 is given by Q by C, which is measured with the help of this metal electrode. So the pressure applied is converted into an electrical voltage. So let us see the advantages of piezoelectric transducer. It has rugged construction, small size, it has excellent frequency response. And the limitations of piezoelectric transducers are, this piezoelectric crystals used are water soluble, so in a humid environment it will get dissolved, so it is a limitation, it cannot be used in humid environment conditions. And second one is the temperature sensitive, so change in temperature affects the output voltage which is measured, and it is used only for dynamic measurements. These are all the various limitations of piezoelectric transducer. Now let us see the applications of piezoelectric transducer. First one, it is used for measurement of non-electrical quantities such as acceleration, vibration, dynamic pressure, etc. So various electrical quantities such as non-electrical quantities such as acceleration, vibration, dynamic pressure, etc. can be measured with the help of this piezoelectric transducer, and it is widely used in aerodynamics, supersonic, wind tunnels, etc. And third, it is also used in ultrasonic flow meters, which is used to measure the flow rate, and micromotion actuators. And also it is used in spark ignition engines and electrostatical dust filters. So these are all the various applications of piezoelectric transducer. Thank you.